The advanced question asks, if there is no seasonal effect on human births, we could expect equal numbers of children to be born in each season, winter, summer, spring, and fall. A student takes a census of her statistics class and finds that of the 120 students in the class, 25 are born in the winter, 35 in the spring, and 32 in the summer, and 28 in the fall. She wonders if the excess in the spring is an indication that births are not uniform throughout the year. Part A asks us, what are the null and alternate hypotheses associated with this question? The null hypothesis would be that there is no association between seasons and number of human births, and the alternate hypothesis would be that there is an association between seasons and the number of human births. Next, it asks us to compute the x-squared statistic, or a chi-test. So we do this using a one-way table of all of the observations and expected. And so let's start at the beginning. The equation for a chi-test is x squared equals the sum of the observed minus the expected squared all over the expected values. So if you were to put all of the values in the problem in L1 and all the expected values in L2, and you calculate expected by taking the total and dividing by the number of categories, so in this case 120 divided by 4 giving you 30 each. And then for L3 you could put L1, because it's your observed, minus L2, your expected, and then square that, and then divide again by L2. So you should get values similar to about these. And then you can exit out of your table and go to your catalog and find the subnation symbol and put L3 behind it, and that gives you the value 1.93 continuing. So we know that x squared is equal to the summation of L3, so that's that. This allows us to check our assumptions for the chi-squared test, being that 80% of expected values fall above 5 and none of the expected values are below 1, which we could see clearly they aren't because they're all 30. Lastly, you want to make sure that it's an SRS, and in this case it's even better. It's a census of her entire statistics class, and so from there we just have to assume that her statistics class is a random assortment of students from her high school. Then to obtain your p-value, you go to Stats, scroll over to Test, and go down to x squared here, and then you put in your observed as L1, your expected as L2, and your degrees of freedom is 3, which we'll talk about in Part C, and then you can hit Calculate, and that should give you your p-value right there of 0.586, whatever. I rounded it to 0.59. So you can see that p-value right here on the paper. And then to readjust, we got the degree of freedom of 3 from taking the number of categories, or the 4 seasons, and subtracting 1. And then our alpha value is stated in Part C, which leads us to Part C. That should say C. What can you say about, or what can you conclude about the null hypothesis at an alpha value of 0.05? And we can say that we failed to reject the hoe that there is no association between the seasons and the number of human births because our p-value of 0.59 is greater than our alpha value of 0.05.